very much. We need to move on to the next presentation. The title is Spatial Data in the Age of COVID-19, Lesson Learned in Managing, Serving, and Teaching with Public Health Data. And our presenter, I believe, is Stacy Curry-Johnson.
Yes, we're two of us presenting, Natalie Robbins and myself.
Very good, thank you.
Can we possibly use our own slides?
Sure.
Okay.
Yes, feel free to share your own slides.
Okay. Let me, this may be a little bit more challenging than I thought.
Should we go on with the slides that we have on the screen?
Yes, I'm having a trouble. I'm having trouble to.
Let's continue just for the interest of time.
Absolutely.
Okay. Please.
Yeah, so welcome to Spatial Data in the Age of COVID-19. And so if you can advance our slides or give one of us control. I'll let my co-presenter, Stacy Curry-Johnson, introduce herself, and then I'll introduce myself.
Hi, I'm Stacy Curry-Johnson. I am the geospatial librarian at Vanderbilt University, and I'm also a lecturer in anthropology teaching GIS and remote sensing. And I do a number of things there, but I'll go ahead and move on to Natalie. Next slide.
Yeah, you have control.
So hi, I'm Natalie Robbins, and I'm a program manager at the newly created Vanderbilt Institute for Spatial Research. And I basically serve as a GIS consultant for researchers across the university and the state of Tennessee and projects outside that realm as well. So just to give you a bit of context on this project, my team and I created and started working with a lot of this COVID-19 data in the very early days of the pandemic. So we identified a need for some sort of visualization about COVID spread and where kind of things were happening and advancing and as far as COVID in Tennessee pretty early on. So once the safer at home in place order happened, we were kind of on the front end of creating a map. And you can see that we created a map in sort of early March of the pandemic, and there was not like an official command center map that was put out by the state until about a month later. So there was a timeline in which we were kind of bridging the gap for information in terms of COVID-19 with our team here at Vanderbilt. So in doing this, we really wanted to try to replicate something like the Johns Hopkins dashboard for Tennessee, but again, identified that need for a geospatial visualization because this type of data is inherently geospatial. And we also wanted to understand spread in the context of Tennessee itself, especially because we have sort of a issue with healthcare deserts here in Tennessee. And then we have sort of these disparate areas of like very rural and then very urban populations. So in doing that, we first created the Tennessee COVID-19 map, which is an ArcGIS dashboard that was created and showed case counts, death counts, and then also American Community Survey, ACS metrics for Tennessee. And this was sort of our first iteration of using this COVID-19 data. And there was lots of different things that went into this and these metrics that were updated daily along with the data itself. From there, we started pushing out hosted content. So as anyone who knows and has worked with data in ArcGIS Online knows, you get all this data and it's publicly shared. So we just wanted to make it available to anybody who was interested. And we were looking at things like case counts, super spreader areas such as Department of Corrections and long-term care facilities. And then again, those health and demographic metrics that we got from ACS data. And then we also had a couple CSV files that I was maintaining just to kind of populate some of those informatics on the side of the dashboard, and we made all of that available to whoever wanted to use it. And so in doing that, we created the Tennessee COVID-19 data portal that basically is a hub site that houses all this information that we were serving out, and then also had all of these dashboards and some additional charts showing spread in the very metropolitan areas of Tennessee, just as kind of a one-stop shop for all of this data. And this is what we've been using a lot as well, Stacy and I, in our teaching with this data. Students can just come in here, grab the data down as a REST API and use it in any sort of project in ArcGIS Online or in ArcGIS Pro. So we had a few challenges at this early kind of stage. There was non-GIS friendly data dissemination. So Excel files, well, it started with PDF files, which is always fun to try to manage into a geospatial format, and then into an Excel file. The data was constantly evolving. We were learning new metrics. We were getting better information more frequently, sometimes less frequently. There was a lot of data discrepancies as well between local and state reporting. So at many times, the data that was coming out of Metro Nashville would be barely different than the data that was being posted by the state. And that had to do with how they were reporting the out-of-state cases. Some were tying it to, so Metro was tying it in with their counts every day. And then the state was kind of parsing that out. And there's a ton of different sources. So, I mean, as we touched on in that first presentation, there's a lot of data being thrown out there. So it was a decision about what the best one of these sources was to use for our mapping purposes. And then there was some hosted data that was available through the state, things like hospital locations and testing locations. But you had to really mine for those REST API using developer tools and get them. They weren't being shared publicly in an easy to access format. So just kind of touching on some of the data wrangling that had to be done, there was a little bit of cleanup that had to happen to filter out kind of the non-spatial aspects of this. And then a lot of kind of transposing and overwriting of data to make it into a format that was usable in the dashboards schema on ArcGIS Online. And then again, you know, just more data wrangling for this case data. And the thing that was kind of interesting is every day at 2, the data was supposed to come out, and some days it would be at 2, and then some days you wouldn't get data for a couple of days. So there was a ton of different discrepancies in that sort of area as well. Some additional challenges is that there's a lot of different hands in the pot. I mean, in any sort of disaster response like this, there's going to be a lot of people working on this, but especially related to super spreader facilities like the Tennessee Department of Corrections was handling this spreading data for the prison system, and then Department of Health was handling it for long-term care facilities, and it was a little bit wonky how that was all kind of being presented. There was no real centralized data stream for different metrics of interest that were kind of evolving as key ways to understand the pandemic. Again, ingestion into GIS was just difficult because of the formatting that kept changing and was not super friendly to begin with. And then there were so many different varying scales that we could present this information at. We had to kind of decide and streamline what the best way to present the information was without overwhelming the user. And now I'm going to toss it over to Stacy to take over this portion.
Excellent. So I'm going to talk a little bit about some of the lessons learned and some recommendations we have moving forward for future disaster events. Okay. So one would be, in terms of our recommendations, would be like data disseminated in just one format, having a standard format, preferably a CSV, of course, and then having REST APIs that are shared out through open data portals for GIS users to connect to directly into their applications. And then having state and local entities having an agreed upon data dissemination standards that everyone agrees to that match up front before they disseminate out to the public. Okay. So for example, like New York State Open Data Portal would be built into their Open Data Portal, which we've all seen these great hubs out there. They already have their COVID-19 data built into their Open Data Portal. But in Tennessee, that's not currently the case. And so they're there, but you have to find them in a different location. And so having that one-stop shop for all your other variables and data, along with that COVID-19 or disaster data, would prove more efficient. Also, in terms of the data dissemination standards, some recommendations would be to have all this syncing with the data coming in, out, what's being shared outwardly. Having everything synced together at the same time consistently would be hugely beneficial. Since the data having it draw from one master data set instead of all these other little places that you have to pull from, so that there are not this uncertainty or discrepancies between local versus state numbers. So having Nashville Metro being in the same kind of data set format as the state, and having everything match up apples to apples.
Yeah, and I'll just speak to that just really quick. And one thing that sort of happened in that realm is that people wanted to get the most updated information out. And so at some point there was a lag between local reporting and state reporting. So the local users said, oh, we'll just push it out so that everybody has the most updated information. And then the state is pushing out something that's a little bit different and lagged a bit. And so then people started to question, what's the true data? Are these counts accurate? Why is it a little bit different in each? And that's caused some concern among viewers of this data.
So how can universities, local organizations kind of play a part in helping with the state and local partners? So universities can partner with these state entities to kind of help develop these standards for dissemination of public health data quickly. So getting guidance from researchers on best data formats and types of automation, which automation would be hugely important to this, but having that guidance really up front for the next event that happens, having that planning up front, working with these different partners could make things a lot more transparent and accurate. Also, organizations like we have in the state of Tennessee, as many states do, a GIS organization. So our Tennessee Geographic Information Council could work with state, because a lot of members are also state employees, communicate with state GIS leaders and metro and city governments to help coordinate these data dissemination factors and standards. So GIS user to GIS user communication is critical. Okay, so from the university library standard, from academic libraries, these could be used as stewards and curators of this pandemic or whatever type of emergency health data comes through. So not only for archival purposes, so archiving the data, but also being there to do with metadata standard quality checks, making sure everything is the proper format, and then being able to then distribute such data sets to multiple sets of departments on campus or across different universities across the state, and then being able to distribute widely across the country in terms of having this standardized data set. And then also be able to mitigate misinformation. So as these different data sets were coming in, like Natalie said, being able to say which one is going to be the reliable one to recommend for analysis or use for analysis is key. So being a partner in that type of mitigation of misinformation.
Sorry for interrupt. You only have 2 minutes left.
Okay. So we will just speed on through here. This is just a really great graphic. We're visual people, right? So we want to go ahead and show you that this is a great way for us to do how show research is interacting with local government, nonprofit, state agencies. So we'll just keep moving through these for right now. Same thing with how we respond to public health. So let's just talk about a little bit about the role of the CDC in all of this, because they do have a part to play. So having a baseline state and county data set that are then aligned with all state agency numbers, critical. Guidance on important public health tracking metrics could come from the CDC, which would influence the standards. Guidance on from how to count, like Natalie mentioned earlier, this out of state, so in tourist areas or places where people visit, how do we count these? How do we account for them spatially within their data set? Okay. Some positive outcomes that have come from this is just a lot of collaboration, but we now have improved state data sets. We have updated hospital locations and health centers, testing locations. Data sets for the portal have been applied to so many projects. So not only for Natalie and I are using these with students for story mapping, but in some of my research looking at geospatial access to this rural access to care, looking at this discrepancies between rural and urban access, this data has played a huge part. And then Natalie has worked extensively with the HIV mobility study, which I'll let her mention real quickly.
Yeah, we've sort of repurposed some of this data for different purposes in this HIV study. So it's been a bit of a blessing in disguise to have this data already available to then repurpose for different types of studies.
Yeah, and the final thing there is that this building, we also have a world-renowned Vanderbilt Hospital here, medical center. So now we've built partnerships with them involving their COVID data and COVID research to help look at like environmental determinants of health as well, incorporated into those studies.
And then just sort of one of the last really nice things is updates to ArcGIS Online. So the new dashboard creator is awesome and has incorporated things that have made creating these a lot easier. And some of the ways that I kind of had to finagle the data in the start of this have been mitigated, which is really great to see these products responding to what GIS leaders need. And with that, we'll take any questions.
Thank you. Any questions? Yes.
So I was wondering if you ran into the same problem I did with the public health side of this equation, where they don't understand the concept of periodicity and infection rates.
Yeah, it's also like really difficult sometimes as like a GIS user to try to communicate like what you're trying to do and back and forth. And so that's sort of where we were hoping that maybe in the future, like GIS to GIS conversations can happen, and then we can get better at like understanding each other, because I think that was kind of a big challenge.
Yeah, it really leads to a lot of uncertainty when the public health students and stuff are never taught that infection rates have a periodicity variable that is in there. So they just think whatever the data is divided by the number of cases is just the infection rate. And so I ran into that with our university public health in Nebraska. So I'm glad somebody else ran into it.
Yes, it's nice to have fellow users of COVID data.
Yeah.
This is Nick Chrisman. Professor Ed Horwood published around 1975 a list of rules of data in this kind of field. And one of them is that the data you have was collected for the last crisis.
Yeah.
And one of the things here is I doubt that anybody thought that the Bureau of Prisons or your corrections department in Tennessee was a public health agency. So when you create the state consortium, I don't think anybody included prisons as, you're right. And so later you find out, oh, we separated things by theme, but corrections is actually also a public health agency.
Absolutely.
So I think one of the things we're learning here is that the interactions we need to foster are not the ones that we planned for.
Yeah, and I think that's super important to keep in mind for, the next public health emergency is like better coordination and better understanding now of like what entities might need to be involved, and sort of a more coordinated response among individuals. Whereas I think in Tennessee, we saw a lot of kind of individualistic responses as opposed to a more holistic approach.
Yeah, and then like developing that proper like communication language to work with non-GIS users, like the leadership and people in these agencies, how we communicate what we need to kind of make this happen. So.
Do you want to mention, or do you have a question? Okay, well, thank you. We can move on to, oh, Eric has a question.
Yeah, I had a
Yeah.
question. I hope you can hear me, and I think it's overall for the the topic on uncertainty and health, and the question, because you talk a lot about the data collection, data through different agencies, and the question I think we also need to ask ourselves is, when are we satisfied with the data that we have collected or we have arranged from different agencies that we can do analysis, and it's sort of, when is it mature enough in order to do this analysis, right? So you could argue, for instance, if you were doing this analysis on space-time analytics on COVID-19, 1 month after the epidemic started, or 2 months or 3 months, the data we had was probably not reflective of what was happening, but then you still have to do your analysis. And so I think it's more of a collective effort to think about, when is my data good enough so that I can do my analysis in general. And it was so exemplified with COVID-19, I think now you can go back and do retrospective analysis, no problem. But as the epidemic unfolds, and when are you confident about your data?
Yes, and making sure to identify like the flaws within the data. That was something that we really learned, like, this data is only as good as what we can get. And we chose to go with the state data set because we felt that that was the most complete and representative for our study. But, just really presenting like this, here are the limitations of the data that are presented to us from the state. There's nothing more that we can do to enrich this to be further, precise or anything. And then making sure that others understand that, because we did get so many questions about limitations of the data and things like that.
Thank you.
Thank you all. We can move on to our next paper.